Good day, panelists. Today we will be presenting our research entitled Development of a Non-Contact Two-Tier Biometric Security System for the DSWD 4Ps using iris recognition and speech recognition. I am Gerard Albert H. Tuazon, and the other proponents for this research are Alfonso J. Enriquez III, Engineer Erickson D. Dimaunahan, and Engineer Alejandro H. Ballado Jr. Now, the objectives of our study are to develop an iris recognition system using rapid Haar wavelet decomposition and a speech recognition system using deep learning where the user's authenticity is verified by the iris recognition system. Now, the study's objective also addresses the accompanying issues in cache aid distribution, particularly in the DSWD4Ps. And of course, it evaluates each system's performance in terms of the FAR and the FRR ratio. Now, for the system process flow, for the ATM enrollment phase, it starts when the user enrolls in the bank with the help of the admin. Now, after they have enrolled in the bank, they'll be getting their account number and will be asked to deposit a minimum balance. Now, after going through that process, they'll now proceed to enter the ATM booth for the enrollment of IRIS and security questions. Now, when they enter the booth, the first thing they need to do is choose a language interface, which can be done by saying the start command for the English interface or magsimula command for the Filipino interface. Now, after they choose what language interface they'd like to use, it will be prompted on the screen the different types of services that they can use, which in our case is to make a withdrawal, balance inquiry, and account enrollment. Now, of course, once they've selected the account enrollment, they'll now proceed to enter their account number through the use of speech recognition system. Now, if their account number is invalid, they'll have to retry, but if it is valid, then they'll proceed to stand 10 centimeters away from the camera to begin scanning their iris. Now, if their iris is not detected, then they have to fix their distance or angle positioning so the camera could detect their iris and start scanning. Now, once the iris is accepted, the user will now be asked to provide three different answers for three different security questions. Now, if their answer is not valid, then they'll have to re-enter. But if it is valid, then the screen will prompt that the enrollment is complete. Of course, the system will also ask the user if they will be using the same type of services again. If they are, then they'll just repeat the whole process. But if not, then that will be the end of their transaction. For the ATM transaction, they will basically do the same thing, where when the user enters the ATM booth, they have to choose a language interface by saying the start command for the English interface or magsimula command for the Filipino interface. Now, once they've chosen the language interface they'd like to use, the screen will prompt the different types of services available. And of course, for this one, they'll be choosing the withdrawal transaction. Now, after that, they have to choose the amount of money they will withdraw and then proceed to stand 10 centimeters away from the camera to begin scanning their iris. Now, if their iris is not detected, then they have to fix their distance or angle positioning so the camera could detect their iris and start scanning. Now, once the iris is accepted, the user will be given 3 attempts to answer the security questions, and if they use up all the attempts, they will be prompted onto the process C as seen on the figure. But if the user answers the question correctly, then the transaction will be a success and they'll be getting their money. And of course, the system will ask the user if they will be making another transaction. And if they say yes, then they will be prompted onto the process C. But if they say no, then that will be the end of their transaction.
Now, for the setup of the prototype, looking at the figure on the left side, that is the experimental setup, while looking at the other figure, that is the actual experiment setup. The camera was placed for a height of 156.41 centimeters, since that is the average height of a Filipino. The capturing distance between the camera and the user, that is 7 to 10 centimeters, but the accurately capturing distance is about 10 centimeters. The camera, Raspberry Pi, and the microphone are directly connected. Now, for the calibration process in terms of iris and speech recognition system, for iris recognition system, we'll be needing to capture a sample iris image, then observe this captured iris image. If this is detailed enough, then the calibration is successfully done. But if not, we need to adjust some parameters like adjusting the focal length, iris positioning of the user, and the image thresholding. Now, for the speech recognition, we'll be needing to speak the assigned words using words assigned in the system and assess these recognized words. If this was recognized by the system accurately, then the calibration is successfully done. But if not, we need to recalibrate and re-record words. So when recalibrating words, we need to use a synonymous words or alternative words that could be easily pronounced by the user or easily recognized by the system. Now, for the results and discussion, first for iris recognition summary of results, here we have the 10 users, and each user has a 10 samples. This is equivalent to 100 samples overall. And two of them got 100%, two of them also got 80%, and one of them got 90%. The lowest accuracy is 70% for this testing. And in the verified column, this is just an indicator. So 1 means verified and 0 means not verified. The error occurs during the iris scanning. It could be in iris positioning of the user or the quality of the iris pattern. Now for the speech recognition summary of results in terms of security question, here we have 3 questions. Each question has a 33 samples and equivalent to 99 samples overall. The first question is, when was your father born? Next question is name of your favorite pet, and the last question is name of your favorite cousins. And now for the accuracy rate, it shows that the first question has a 94% accuracy rate compared to the two questions, which got a 85% for both questions. It shows that it's more easily to recognize by the system or pronounced by the user the year compared to the names of your favorite pet or favorite cousins. It shows that the errors for this part is caused by the unrecognized words by the system or the wrong answers given by the user. Now, for the results and discussion under the speech recognition in terms of navigation, here we have the English words and Tagalog words. Each words has an accuracy rate. Looking at the accuracy rate for the word start and magsimula, it shows that it is 80%, as well as for the word proceed and retry. This error occurs during the words not recognized by the system, or some people tend to like to speak the word start as start than start. That could affect the system. Now, for the results and discussion in terms of FAR and FRR results, as well as for the accuracy, for the iris verification, we got a 13% for FAR and 3% for FRR, having an accuracy rate of 84%. While for the security questions, we got a 0% for FAR and 12.12% for FRR, having an accuracy rate of 87.88%. While for the navigation, we got a 0% for FAR and 3.62% for FRR, and having an accuracy rate of 96.36% for the navigation.
In conclusion, we were able to apply the algorithm Haar wavelet decomposition for the iris recognition system and the Google Speech API for the pre-trained machine learning for the speech recognition system. For the accuracy of the whole security system, we were able to accumulate an accuracy of 84% for the iris recognition, 87.8% for the security questions, and 96.36% for navigation. We were also able to build a non-contact two-tier biometric security system specifically for the DSWD4Ps, having different transaction features like making a withdrawal, balance inquiry, and of course account enrollment. Now, this ATM system has a preferable language where it could be performed through English or Filipino languages, depending on the user on how he or she will use it. Now, the error occurs during the iris scanning, commonly due to the iris pattern quality and the iris positioning. Since people tend to wink during the iris capturing, that could affect the process of the iris segmentation and could lead to an error in the system.
Now, for the recommendation, we recommend to use a high-quality camera having a specification of 8 to 12 megapixel. This will improve the quality of iris pattern. Another thing is to have a thresholding process for the refraction reduction. This will improve the process of iris segmentation. Another thing is to add more transaction features, since in this system, it only includes the withdraw, account enrollment, and balance inquiry process. And another thing is the high specification a microphone For speech recording, this will help the system to easily recognize the words. And the last thing is to improve the actual setup of the prototype. That's all for our presentation. Thank you.